Welcome back to my YouTube channel all about VLSI. In this particular series, we were discussing about RISC-V processor design, and before that, we were discussing about prerequisites about computer organization architecture, like what do you mean by fetching and what do you mean by decoding and what do you mean by an instruction and all. So these are the prerequisites which we were discussing, and as a part of that particular discussion, let's try to understand different kind of computer architectures. One is von Neumann architecture, which is a very famous architecture. It's a computer design where instructions and data are stored in the same memory space. Now, what do you mean by an instruction that we have already discussed in our previous sessions, right? And what do you mean by data? Data is nothing but your raw data, like your information, right? So those particular instruction as well as data is stored in a same memory. That means our CPU is going to fetch both the instructions and data from the same memory using same pathways. So this is what it is meant by this. So we are going to have the central processing unit, our processor. This particular processor is going to fetch the instructions and whatever the information which we are going to have from this main memory. That means for the instruction as well as for the data, we are going to have a single memory, and it is going to fetch it, and it is going to decode, and it is execute, and it is going to do all the operations, right? So this is nothing but my von Neumann architecture. Now, here the main memory is nothing but this is where data as well as instructions are stored, and it is going to store the variables, like if I'm going to write down int a is equal to 10 and b is equal to 20 and c is equal to a plus b, it is going to store the value of 10 and it is going to store the value of 20. That is nothing but my data, and it is also going to store the resultant of this particular operation, right? And this main memory is going to hold both program instructions as well as data values. Now, here, the CPU does not compute directly from the memory. It is first going to fetch the data into the registers, and it is going to execute them. For example, it is going to use a RAM or DRAM, right? Now, let's try to understand what do you mean by CPU and what do you mean by central processing unit. So basically, it consists of registers, control unit, and ALU. Now, what do you mean by register? Basically, these registers are small, ultra fast storage elements inside your CPU. These are basically used where your main memory is very slow compared to your registers, which are very fast. If your processor wants to fetch each and everything from the main memory, that is a very slow operation, right? So that's where you're going to use these registers, which are actually cache memory, small memory, where they are going to use it by the processor for fetching the data very fastly. Okay. And what are all the information your processor is going to fetch from this registers? It can be operands, or it may be intermediate results for storing the intermediate results, or it may be for accessing the different kind of addresses, right? Now, and there will be one more thing which is known as control unit inside your CPU, which is like a kind of decision maker or a controller, which is basically used to fetch the instructions from memory and decode the instructions and generate control signals. For this, we are going to have control unit. And why are we discussing them? Because when we are going to start with a RISC-V processor design, these are the fundamentals. This is what we are going to implement in our RISC-V processor also, right? And for example, if I'm going to have an operation like C is equal to A plus B, our control unit is going to tell to fetch this A and B, and it is going to give the instruction to send that particular thing to the ALU. ALU is going to give me the result, and that particular result it is going to instruct, or it is going to control, or it is going to tell to store it in my memory. So this is how the operation is going to work. And next is arithmetic and logic unit, where the actual computation is going to happen, like addition, subtraction, or shifting operation, multiplication, division, right shifting, left shifting, and all particular operations are going to happen inside my arithmetic logic unit. And input and output systems, this is basically going to be connected to the computer, to the outside world, like keyboard, sensors, or switches. It is just for connecting with the peripherals. Input output system is for connecting to my peripherals, like displays, LEDs, and peripherals, right? So this was about how your processor von Neumann architecture or a processor is going to look like. So this kind of architecture only we are going to build using our RISC-V IP processor, right? So it is going to have a main memory and a central processing unit where it is going to have registers and all. Now, coming to another kind of architecture, which is hardware architecture. Before that, if I want to summarize what is that going to happen is, first, my processor is going to fetch the instructions, then from the main memory, and it is going to decode it. and it is going to read the operands and it is going to execute it. And after ALU going to perform the operation, it is going to write back to the main memory. Whatever the result which we are going to get, it is going to written into my main. So what is the bottleneck of our von Neumann architecture is whatever we do to enhance the performance, we cannot get away from the fact that instructions can only be done at a time, one at a time, and can only be carried out sequentially. So both these factors hold back the competence of our CPU, and this is commonly referred to as von Neumann bottleneck. So we can provide a von Neumann processor with more catchy, but more addition of RAM or faster components, but original gains are to be made in the CPU performance, then an influential inspection needs to take place of CPU configuration. So this is a major bottleneck which we are going to have. And also one more major important point is that even all the instructions and data are going to be stored inside your main memory. This is a very, very important thing which we are having, right? And applications is you can use in your personal computers and laptops and smartphones and tablets. And coming to other kind of architecture, which is hardware architecture, where it's a computer architecture in which instruction memory and the data memory are separate. So here you are going to have separate memories for instructions and separate memory for your data, right? Where the program instructions are stored in instruction memory and data is stored inside your data. And hardware architecture, as I've shown you, it is going to have separate buses for your instruction as well as separate bus for your data. So processor can fetch the instruction and it can also fetch the data at the same time, whereas it cannot. Von Neumann architecture, we cannot fetch the instruction and data at the same time. First, we need to fetch the instruction, then we need to fetch the data sequentially. So that is the difference between these two kind of architectures, and that's about this particular session. If you and in our next sessions, we are going to see more about this kind of basics. Like we are going to first of all discuss all the prerequisites and basics which are needed. Then we are going to start building our risk-free processor, right? So that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.